thanks everyone for coming tonight. I'm Yves-Alexandre de Montjoye. I head the computational privacy group at Imperial College in London. Today, I'm going to talk to you about big data and privacy, and how can we use data in the modern world while protecting our privacy. So the first thing, and before we start, I'd like to tell you a little story. So who knows CSI, the crime drama television series, and likes it? 10%? Okay, so that's the kind of show that we at Imperial love. I mean, scientists saving the day with superpower. What's not to love? And one of my very favorite episodes, it's really interesting because from the very beginning, they have a pretty big hunch at who the killer is. Just they don't know how to prove it. They don't know how to prove that he's actually the killer and arrest him. So what they do is that's usually in these kind of episodes where basically the scientist shows up and he saves the day with, superpower. In this case, fingerprint. Basically what happened is that someone got killed, and in the apartment there were like fingerprints traces all over. So what they did is they collected all of these fingerprints. And then the guy they suspect to be the killer actually pretend he doesn't know the victim. Never seen her, never been there. So actually, if they can prove that the guy was in the apartment, that would be sufficient to actually, get him off the streets. So what they do is basically they have an agent that's going to follow the guy around. So they follow him. And at some point he stops at a bar. And then the guy is basically at the bar, sitting on a leather couch, drinking whiskey out of a crystal glass, hanging there. And at some point he goes to the restroom. And that's the time where the agent just goes and run, catch the glass, and bring it back to the lab for analysis. There what they do is they take the glass and then they collect the fingerprint out of the glass, right? They just come with a little piece of paper and then take the fingerprint of the glass and then enter it in the computer. Try to see if it matches the fingerprint that they collected in the apartment. Then we wait, wondering, is it going to work? Is it going to match? Is it really him? Can we finally arrest him? And so on and so forth. Waiting. The computer is slow. It's obviously old computer. You wait. Green numbers start falling down the screen and so on and so forth. And at some point, finally, it's a match. It actually matches one of the fingerprints that was in the apartment. They can now finally go arrest and prosecute him. And the thing is, when you think about it, it's actually not that easy, right? I mean, how can you be really sure that the fingerprint that you got from the glass is actually the same than the fingerprint that you got from the apartment? I mean, you can't just look at them, right? You can't be well, it looks close enough, right? If you're gonna go and arrest a guy, you better be pretty damn sure that the fingerprint actually belongs to the person, that the two fingerprints actually belong to him. And for that, the CSI team should thank this guy, Edmond Lecard. Frenchman, in the 1930s, wrote a book called Traité criminalistique. Basically, in this book, what he showed is that, on average, to be able to compare two fingerprints, all you need are 12 points. They're just point of the fingerprint. Basically, they're just, distances between ridges. And if these 12 distances are close enough to one another, really close, you can be sure that these two fingerprints belongs to the same person. 12 points is all what CSI's Russell need to be able to arrest the guy. And since then, fingerprints have been used extensively to find and identify people. But today we're leaving behind a lot more traces than just fingerprints. People who go running with their phone and the GPS on. Allows you to, produce these very beautiful visualizations. Data coming from your phone. Every single time you make a phone call, you send a text. every single thing that you type in this little, like, text box, search box on Google, and which link you actually clicked on. Anytime you, swipe your credit card to buy something, every single one of these generate one of those lines. So, when you look at this, sure, there's a lot of good thing you can do with it. At the same time, at some point, someone in the room starts to feel uncomfortable. At some point, people are like, well, it might be sensitive. People might be searching for things that, they don't want you to know. Maybe I don't necessarily want someone to be able to track, every single place I've been going to in the past year. And often what you hear back is that you shouldn't worry, right? It's fine, right? We don't know, who, the person 142 who has been doing these searches is. And if you take a lot of real-world examples, you see the same argument over and over again. This is an example from London in which the TfL was basically running a Wi-Fi trial, basically recording every single Wi-Fi that every single phone passed by in the subway system. And you can see a bunch of information and so on, but basically what it says is that anonymous information was collected and that you shouldn't worry, right? The data was depersonalized, whatever that means, and so that no individual can be identified. No reason to worry. It's anonymous. You can find the same nearby here in Belgium. Recently in Antwerp, using mobile phone data to better understand how people are moving around the city. Again, same argument. Sure, it might be sensitive. At the same time, you shouldn't worry too much, as Dr. Weaver says. We don't know whose mobile it is. The data is anonymous. It's fine. So really what we wanted to address with my research group as a question is really to see whether this is actually true. Is the fact that there's no name, no phone number associated with this data sufficient to truly call this data anonymous and to make it okay? In other words, is the way I and every single one of you behaves generic or specific enough that it could uniquely identify you? Is the way you move around, the way you, pay for things, the way you search things on Google, as unique as your physical fingerprint? And to answer this question, we developed a metric that we call unicity. And the goal of this metric is really to try to take a statistical approach and be like, okay, what would it take? Right? In the past, we've seen with fingerprints, you need 12 points. You need 12 points to be able to match the fingerprint from the database to the glass. What would it take with mobile phone data? What is the average risk of re-identification? How much information do I need to know about every single one of you to be able to uniquely identify you? Let's say that I'm searching for Scott. Scott's in the database, I know him, and I want to know where he has been going to. And fingerprints, would be ridges and so on, right? Really trying to compare the two fingerprints to, low resolution images. When it comes to mobile phone data, a point could be, for example, something like this. He lives in Boston. I know that he was there in Beacon Hill between 10 and 11 a.m. in this region of 1 kilometer square. And I can keep following him around. I can know that he went to Cambridge afterward, and then he went to Waltham, and so on and so forth. So the real question is, how much does it take? How many points do I need to be able to uniquely identify Scott in one of these databases? How much information do I need to know about him? So let's do a little poll. So when it comes to physical fingerprint, you need 12 points. 12 of these metrics that needs to be close enough. How much do you think we need, a place and a time? How many places and times do I need so that in the entire database, in the whole of Belgium, you're going to be the only person that will have been at these places at these times? So I can't really see too well, but let's try to do a poll. Who thinks that we need more than 15 points? Raise your hand. 15? Couple of hands. Okay. 10. Okay. 8. Okay. More. 6. Okay. 4. Okay. 3. 2. 1. For those who have not been following, this was your last chance. I mean, why don't we try, right? I know Scott, I know a certain number of pieces of information about him. Let's give it a shot. So I know he's in Boston, I have this large database. And then what I'm going to do is very simplified. Basically, I'm going to look at places and times where I know he was. And if the person was not there or around there, I know that it can't be Scott. So I start 1 point. Second point, I know he went to Cambridge. Third point, I know he went to Waltham. And finally, a fourth point. I know that he went back to his home where he lived in northern Mass. And as you can see, you start with a lot of traces, like lots of people, like this is Boston, like 8 million people all moving around all the time. But very quickly, a small fraction of them will actually be where my first point is. And then a smaller fraction of them are going to be where my second point is. And then a much smaller fraction of them is going to be where my third point is. And basically, by the time I get to my fourth point, there's one and only one trace in the database that could be Scott. I know we identified him, and I can follow him around. This is just a little video to give you a sense of what we've been doing, but we actually did the research. Took a large-scale mobile phone dataset, real dataset, 1.5 million people that we followed over 15 months. And in that dataset, we show that knowing 4 points, 4 places and times where someone was, is enough to uniquely identify him 95% of the time. You feel you're very, you're in the crowd, right? There's so many people here tonight. The thing is, a small fraction of them will then go back to the same place at midnight than you. And a smaller fraction of them is going to go to work with you tomorrow, and so on and so forth. And this decreases fast enough that 95% of the time, all it takes to uniquely re-identify someone in a data set of millions are 4 points, 4 places and times. So, where would you get this from? Well, I mean, I can know you, know where you live, I know where you work, I could look at, your Twitter feed, every single geolocated tweet, like not exactly the GPS coordinate, just the neighborhood of Brussels you're in. I could look at, geolocated pictures that you've been posting on, Instagram or Facebook. I can look at restaurants reviews, every single place you've been going to get dinner. Looking at this, I know that Jean, a friend of mine, went to this restaurant in Alsace on January 4th, where he got oysters that apparently are good, but slightly overpriced. And basically, every single one of these points, on average, if you have 4 of them, is sufficient to re-identify someone, is sufficient to find him in a data set of millions. So what we wanted to do then is, we're good scientists. What we wanted to see is is this something special with mobile phone? Right? Maybe something in the way you move around and in the way you use your phone and you're spending too much time texting might make you very unique. It's the same true in the other data set I showed you at the beginning. So we wanted to try. I don't know what the statistics are for Belgium, but in the US, 75% of the time when you go to a restaurant, you're going to pay with your credit card. You're going to swipe your card. So we did the same thing. Took a large-scale bank data set, credit card transactions, same thing that you see on your bank statement. And we tried to see, how many of these 100 tips do I need so that in my data set, there's one and only one person who could be my friend Jean. And basically what we showed is pretty much the same thing. A point, a shop, and a day. 4 of these are sufficient 90% of the time to uniquely identify someone in a data set of 1.1 million people. What that means is that every single time you go shopping, for example, you come back with 4 bags. You know, a lot of people are going to the same shopping mall on the same day. Well, actually, 90% of the time, you will be the only person who bought something using your credit card in these 4 shops on these 4 days. So at least what this tells you is that any reassurances you get from the data is anonymous, shouldn't worry too much about it. You know, we don't know whose, mobile phone this is. At least not sufficient. So at that point, the conversation starts to become a bit more awkward. Then people are trying to come up with solutions. Actually, your data is very precise. I'm not giving the exact GPS coordinates. I'm going to add a little bit of noise. You don't know exactly where I was in Brussels, like only certain neighborhoods and so on and so forth. So that should make it okay, right? I mean, it plays with your intuition, right? If I can take a picture like this and I just, I decrease the resolution, I just add noise, you won't be able to re-identify this person. So we tried. Again, went back to our mobile phone data set, and then basically we did the same thing. We tried to decrease the spatial and the temporal resolution of the data, basically making the data less precise. Try to see if we can start, getting traces to start, basically blur with one another, and blur enough that I cannot, re-identify you, play this little game, collect a few points. Won't have time to go into too much details, and this is the only equation I have in my entire talk, I promise, but it's a really important one. Basically what this tells you is 3 things. 1 good news, 2 bad news. 1 good news is, yes, if you start decreasing the spatial and the temporal resolution of the data, it will make it harder. Right? There's a lot more people that will be in Brussels on a given day than in this room. Same thing, if I look at a week of data instead of an hour, it's going to be a lot more people. That's the good news. Bad news. First one is this is a poor function. So basically what this means in economic terms is that you get decreasing returns. So every time you try to gain a little bit of privacy by adding a little bit more noise, it makes you feel good, it reassures the lawyer, should be okay. Every time you do that, it becomes more and more costly. To decrease the likelihood of re-identification by, say, 3%, you need to go from 1 kilometer square to 2 kilometers square. Then if you want to go again, decrease by 3%, you need to go from 2 kilometer squares to 4 kilometer squares. And then from 4 to 8. So at the beginning, you gain a little bit. Very quickly, you get decreasing returns. That was the first bad news. Second bad news is this little p in the exponent. And basically what this tells you is that you can try to decrease the resolution of the data, spatially, temporally. At the end of the day, it's just going to be a matter for me to collect a few more points. It's not going to be 4, it's going to be 5, 6, 7, out of the hundreds that I can find online. So basically what this tells you is that, at least when it comes to large-scale behavioral data sets, mobile phone, credit cards, smart meter, what you type on the Google box, simply calling the data anonymous and adding a little bit of noise is by no means sufficient to make it truly safe to prevent re-identification. Now, what's really interesting with the metric is that you can go a little bit further. You can see how much easier or harder can you make it. So we try to look, for example, at gender in credit card data sets. And what we're trying to do here is to see which gender is easier to re-identify. Basically, what this tells you is that women are actually a lot easier to re-identify than men in credit card data sets. Good. So, for everyone who has been laughing, the reason we could find in the data for this result is actually not the amount you spend, how much you buy. The only differences we could find between the two genders is actually how you distribute your purchases. So basically what it means for all of the guys who have been laughing is that you're going to go to the same shop, buy the same shitty stuff, and just go back home, when women would actually have the taste to go to the right shop to buy the right item. And that is what makes it more unique. Can do the same with income. Pretty much the same reasoning. High-income people will go to specific shops that low-income people cannot afford. That makes them more unique. So what's really interesting here is that we have a metric. We have a way to try to judge whether, quotes of data is anonymous, you shouldn't worry too much, this is not really your data and so on, are actually sufficient to preserve privacy. And what I just showed you hopefully convinces you that, taking the data set, removing names and phone numbers, add a little bit of noise, by no means sufficient. And this is a lot of research that we've been doing for the past 5 years with my group that got us, a lot of press, covers and so on and so forth. The main thing, though, is, the person who really wants to use the data at some point is going to be okay. Pseudonymization, no obvious identifiers, not sufficient. Adding noise, not sufficient. What have you left? Maybe this one, right? Maybe actually, you haven't done anything wrong. Maybe it's fine. Maybe you have nothing to hide. We all heard that argument. It's okay. You know where you've been going. Who has been doing something wrong and doesn't want this data to be looked at? Nobody? One person at the back, Stefan? Maybe it's not that sensitive, is basically what underlies this argument. Sure, it's not really anonymous. Sure, adding noise might not be sufficient. But, maybe it's okay, right? You're just going from home to work. You're not that interesting. Maybe it's fine. So one little game that we played with my students at MIT was we collected their mobile phone data over a couple of months. And then basically we asked them to answer this little questionnaire. So for those who know what this is the BFI, it's basically a personality test. You answer a certain number of questions, you see yourself as someone who's, relaxed, outgoing, sociable, or gets nervous easily. And basically if you answer, these 20 questions, 30, we can basically say, describe your personality along 5 axes. Whether you're low, medium, or high on the extroversion scale. Whether you're low, medium, or high on the neuroticism scale. And this has been used extensively in marketing and research and Cambridge Analytica shit and so on. And basically what we wanted to do is, okay, so you answer this little questionnaire, I can describe your personality. But I also have your mobile phone data, which is not sensitive. We all agree on that. So what we did is we looked at the mobile phone data and then we tried to see, okay, what can I compute? What can I get from this data that might actually tell me something about your personality? And we developed more than 1,400 of these behavioral indicators. How much you call, how much you text, how much do you move around, obvious ones, and then more subtle ones. You just got a text. How long is it going to take you to answer that text? Are you the kind of person who's basically your phone is with you 24/7, and we know that within 30 seconds to a minute, when things are really bad, we will get an answer? Or are you the kind of person like my sisters who would leave their phone aside, and then basically you get a fire hose of answers at the end of the day? Then we're going to look at, like how many towers have you been connected to? Like how much time do you spend at home? And so on and so forth. And then what we try to do is, can we use these behavioral indicators, some machine learning algorithm, and then be able to say something about your personality? And basically what we showed is that just by looking at mobile phone metadata, just by looking at how you've been moving around, how much time it takes you to answer this text, not what you've been texting, not what you've been saying on the phone, not who you've been talking to, just metadata. We can predict your degree of neuroticism up to 1.7 times better than random. We can predict if you're going to be low, medium, or high on this neuroticism scale. Just by looking at this information, just, calls and texts, you've been receiving calls, sending text. 61% of the time, we can correctly predict whether you're going to be low, medium, or high on the extroversion scale. So really what this hopefully tells you is that anonymous, maybe not. Adding noise, maybe not. Maybe it's not sensitive, maybe it's fine. Well, your personality might be useful. But maybe the last criticism is like, these are MIT students. Their degree of neuroticism is nowhere close what the baseline, normal population is. So maybe that's actually what makes it easy. So just as a last little bit, we did the same thing, but we just wanted to predict gender. We took 2 countries, up to 500,000 people, and we showed that just by looking at these behavioral indicators, just by looking at the way they move around and how fast they answer text, we can predict whether this is a man or woman using the phone with 75% accuracy. 75% of the time, we correctly predicted whether this was a man or woman using the phone just by the metadata from the phone, just by the way he uses the phone. So, not anonymous, not adding noise, arguably sensitive, unless someone disagrees and want to, come show us their data. No? So, I think at this point, it's fairly clear that, the kind of statement that you've seen at the beginning of the talk, saying you shouldn't worry, this is mobile phone data, this is to study, good stuff, like the way people move around and manage the crowd and make sure that, the subway system is going to run smoothly. All good stuff. The little thing that says that the data is anonymous and that it's not really sensitive anyway is not sufficient. Fundamentally, under that model, the trade-off that we get looks like this. You're always going to come with a slightly better algorithm and slightly, smarter way of doing things and so on and so forth. But, at the end of the day, it looks like this. Either you can do something with the data, or you protect people's privacy. There's nothing in the middle. So what do we do? Should we, all put our phone in metal boxes? Should we make the collection of data illegal? Should we, jail scientists who are using this data? Couple of yes. The thing is, there are so many good stuff that we can do with this data. When you look at developing countries, for example, and all of the applications that have been developed using mobile phone data in developing countries, that is an argument for which we need to find a balance. We need to reinvent the way we're going to find the balance between using the data and protecting people's privacy. In developing countries, using mobile phone data, people have been doing real-time population mapping. This is trained on France, not that interested in France. Very useful in developing countries. Disaster response, epidemiological models. What has been doing with malaria in Kenya. Other things. For example, socioeconomic status prediction. You're trying to come to a country, you're trying to reduce poverty, you don't really know what poverty is. The latest census you got was 5 years ago. The data is not released yet. With mobile phone data, you can do this in real time on a monthly basis, if you find a real solution to the privacy issue. So to me, these are really motivating examples. This is why, not collecting the data, not putting our phone in a box, putting our phone in a metal box, it's just not a solution. So a lot of what we're trying to develop now is how do we find an actual trade-off? How do we find a way that we can actually use the data and give individuals, every single one of you in this room, much better guarantees than someone telling you that the data is anonymous, it's all fine, you shouldn't worry. And so this is a new project that we're starting, in which basically what we're trying to do is we're trying to keep the promise. Right? Your data will be used anonymously. Doesn't mean the data is anonymous. Data will be used anonymously. And then basically what we do is we develop a whole set of system and verification mechanisms to ensure that the data is being used properly. We don't try to take the data, mess up with it, and then give it to someone and then do whatever you want. We keep the data in-house, and then we allow you to come with specific questions. You want to study how people are moving around Antwerp? We're going to keep the data, and you're going to come with specific questions. You're going to ask us, people have been traveling, commuting, between 8 and 9 a.m. from that region to that region. We're turning the paradigm around. We stop trying to pretend that we can actually anonymize data. We put the data in a safe, and then we very carefully control what comes in and what comes out. And so this is a huge project that we've started developing that's called Opal, where the aim is really to see how we can use data for public good, but in a way that truly preserves people's privacy, in a way that we can come to you and we can show you why this is truly a safe way of doing it. This is something that we call Bring the Code to the Data, something that has been funded by the French Development Agency and the World Bank, that Imperial College develops with MIT. Really on this basis of question and answer mechanism. And really, this is not a perfect solution. But moving forward, not using this data is, like my friend Kenneth Wikier says, it's like burning books. We should use this data. We have a moral responsibility to use this data. But we also have basic human rights. So moving forward, we need two things. First, we need to stop pretending that anonymous is okay. We need to keep people accountable to how our data is being collected and used. And then we need to go to them and I want my data to be used for good. I want my data to be used for epidemiological models. I want my data to be used by scientists, but I need you to give us real guarantees. And really, this project that we're developing, moving forward, is pretty much the only way we're going to be able, in the future, in the coming 10 years, use big data for good while protect people's privacy. And with that, thank you.